Okay. So we're going to talk about two things next. We're going to talk about sector area. Hey guys. And we're also going to talk about arc length. And I've said it once, I'll say it again. A sector is basically a pizza slice. An arc is basically some leftover pizza crust, lonely on a plate. We can measure the area of a slice of pizza, but we will measure the length of an arc or pizza crust. Okay, so first, let's do this. And you don't have to write this whole problem down. I just want you to pay attention. So you ordered a 16-inch diameter pizza. You were hungry, so you ate half of that. Okay? So I have two questions. Question one. What area of pizza, strange sentence, did you eat? Okay, so what is the area of the amount of pizza that you ate from that pizza? Now, let's represent this pizza with a circle. Always a good idea to draw a picture. And so I ate half of it. Well, you ate half of it. You pig. So, I'm going to shade in that half of it, and I want to know basically what's the area of this half of a circle. So, how would I find that area? Think about it for a second. What would I do? Time's up. All right. So somebody help me out here. I told you not to write all this down. Why are you all writing it down? That's okay. So give me an idea. How could I find this area? Austin.
You get an area divided by 2 of the circle.
Yeah. So I'm going to do the area of the circle, which is pi r squared. Good. Remember, area is in units squared. Easy way to remember this is the circle formula, the area formula. And you said divided by 2. I'm actually going to write that a little bit differently. Yeah. I want the area of half of that circle. Okay? So the idea here, very simple, right? It's half of the total area. And when we're finding any size sector, we're going to set up the problem the same way. So we're going to take some fraction and multiply that fraction by whatever the total area is of the complete circle. So what would the radius be here? Yeah, the radius would be 8. Half the diameter. So you'd get 64, take a half that, 32 pi. That'd be the exact answer, inches squared. It's kind of a weird looking answer though. So we're not talking about an angle here, right? It's 32 pi is not the angle of pizza that we ate. What would the angle of pizza be that we ate? Yeah, it's 180 or 180 degrees, or pi radians would be the angle. This is an area, so it's an inches squared. And then, of course, you could approximate it. It's about 100 inches squared. It's like 100.5, something like that. Okay, so that's the idea. The point here is not this, but how we set this problem up. Second question. Because you're a wasteful person, you left all the crust just lying on the plate. That's why you were able to eat so much pizza. So what length of crust is left over after you're done eating that half of a pizza? You wasteful person. All right, so again, I've got half of a circle. So I'm going to draw in that half a circle's worth of crust that's left behind. And this time I'm not measuring its area, I'm measuring its length. So take a second, let's think about it. How would I do this? No.
Find the circumference.
Find the circumference. How do you find the circumference?
Diameter times pi.
Yeah, it's pi times the diameter. Since we're usually dealing with the radius, remember you can also write that as 2 pi times the radius. Same thing as pi times diameter. Doesn't really matter. That's a style choice that you can make. And what fraction of the entire circumference do we want? In this case, yeah, we want 1/2. Okay? And so that's how I would calculate it. And again, it's going to be some fraction times, in this case, not the total area for the circle, but because we want the length of the outer edge, we call it the circumference. Or circumf for short. That's what its friends call it. Okay, so this is the basic idea. And the same thing is true even if you want, let's say, here, separate question. Okay, so blah, 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 calculate it, etc. Your pizza this time, new pizza, you're eating again. You should probably slow down on the pizza. That's a different discussion. So your pizza is cut into angles of pi over 5 radians. So I want to know first, what fraction, how many slices, there we go, how many slices of pizza are there in existence? Second, we'll give the area of each one. Okay. So, first off, how many slices of pizza are there if it's cut into pi over 5? Now, basically what I'm asking is, like, what fraction of the pizza is each slice? So, pi over 5, that's my angle. So, how do I know, like, what fraction of the total pizza that is? Well, easy way to do it, I'm going to make it a fraction. So how many radians, because this is in radians, how many radians are in the total pizza? Hint, it's a circle. Not a calzone. Yeah, there are 2 pi. Okay. So the slice, we put that number on top. And then the total, we can put on the bottom. That gives us a fraction. Now, I can reduce that fraction, and I can figure out how many slices of pizza there are. So, I didn't leave myself much room here. So we've got pi over 5 divided by 2 pi. How do I reduce a complicated fraction? Yeah, I'm going to take the bottom and flip it and multiply instead of divide. Like so. Now I can see that my pi's cancel, and I'm left with what fraction? 1/10. So each slice is 1/10 of the pizza. Okay, make sense? So how many slices are there? Yeah. Oh boy. Okay. The second question was, give the area of each slice. So we said the area is always going to be some fraction of the entire area. What fraction of the area is each slice in this case? Yeah, it's 1/10. And the total area is pi r squared. So how did I figure out that it was 1/10 of the pizza? Well, I took my angle, right? And I divided it by an entire circle. Right? And this is what you do. So we did pi over 5 divided by 2 pi. Okay. So this is really simple. We're going to go over it a little bit more in the next class, and then we're going to do some practice problems. Then we'll review. Then we've got a test on Friday. So try these 1 through 12 for homework. So again, number 1 through 12, that's going to be our homework for today's lesson. Okay.
What was that? Couldn't hear you. No, Caro, you inspired.
Well done.